if we are live, we have the microphone and everything working okay or not. Do this quickly, we don't have much time. Let's see, just need the link for the stream. We'll start in a sec. Try a different type of post on LinkedIn. Hopefully someone joins in. Okay, we'll get to back to fuzzy logic in a sec. Don't know what they add. Sometimes appear on the bottom, sometimes on top. My monitoring doesn't work. Sound monitoring. Have to keep talking just for the testing bit. Is it working now? Yep. Okay, seems like we're using the correct microphone, so that's good. We will be a couple things on the agenda today. Unless you ask some interesting questions, then we're happy to change topics. More than happy to talk about any of those or something close to it, something relevant to it. Now we'll be quickly deploying the website. It's because we had some changes. We also want to make the, what is it that got the name? What was the name? The name was not video processing. That's, by the way, we have an automated thing to process the live streams into much shorter videos. Essentially getting rid of all the silent bits, the like. That's open source, by the way, as well, if you want to use it on your own videos. It should be on GitHub now. So we'll be redeploying the website. So fuzzy logic is still in prototype stage, but could try the current prototype. Maybe you have some suggestions on how to actually make it work better. And we have this gesture groove, which is the music turning hand gestures into music. That one is only JavaScript. Actually happy to delete that copy. We weren't actually doing anything in testing. This is something the bot generated the testing for it. Not actually using it at the moment. And just doing a sound check quickly. By the way, it's okay to say hello. And it will be more than great if you already checked BioniChaos.com, if you checked any of the tools and you have any feedback on them. So that's what I'm doing this for. Doing the live stream. You can do it now. You can go on the site. I mean, it might overload my server. Hopefully not. Probably start seeing it with frames. in the stream being dropped. But so far, so good. So let's deploy it now. Just go for it. Yes, you might not be able to use it for like 5-10 seconds or so. Have those. So we haven't. Okay. So the fuzzy logic won't work because we haven't added the. Need to add the Flask application. Okay, so there's no point deploying it now. I need to add the Flask application first. Did it many times, like 10 times or so. But still, every time doing it, there's some problems. Just quickly, just to get us going. We had this question emailed to us, so we won't be actually posting the original question, but we turned the question into prompts. And the original question actually didn't have any questions, so we turned the prompts into questions. So we have this. Let's read this quickly.
Prompt for generating a PSD plot from EEG wavelet coefficients. Generate a PSD plot from EEG wavelet coefficients for gamma and beta rhythms obtained using a DB5 wavelet. Provide step-by-step instructions. Prompt for advice on implementing PSD after coefficients extraction. Provide guidance on implementing PSD analysis after extracting EEG wavelet coefficients using the DB5 wavelet. Include any recommended Python libraries or methods. Prompt for using an online tool for understanding EEG wavelet analysis. Explain how to use an online tool for visualizing EEG wavelet analysis results, especially in the context of gamma and beta rhythms. Include any relevant tips or suggestions.
Yeah, so the first two are just general advice, and it's already answering those questions, providing code. And this is GPT 3.5. So yeah, I'm always never too sure how much better GPT-4 actually is. In the past, I had some bugs that 3.5 was not able to solve, but GPT-4 actually came up with a solution. It happened a couple of times actually. So it tells you what, yeah, I won't be going into the details of it. We have the tool, so we have some Python code in a Flask application implemented on the website. Actually, a bunch of them that use the same, yeah, have the DG spectrogram. Cross coherence is a different thing. Synthetic EEG, yeah, we'll go in circles after we finish with fuzzy logic and neural networks, and touch on annotating EEG as well. Then we'll start, that's what we're currently doing. Then we'll start going over, we'll add the music, the gesture to music. That's just as a side. That's what I was doing over the break. Quick, fun project. Kind of relates to, considering how much stuff we did with music. So we added another feature that actually someone else was inspired by someone on LinkedIn. Let's just finish with this question. Yeah, it's interesting that GPT was giving quite an extensive code already, answering that question essentially, I think covering pretty much everything you need. Because the original question was how to apply the EEG processing onto your own data. So yeah, so I don't think the original code is required. It would not work on your data. You need to adjust it to suit your specific data set. I think that specific dataset is also not in the public domain. By the way, if you do have any datasets that are in the public domain, please do let me know. Happy to have a look at them. But they have to be public domain. So it's calculating the PSD, which is it's got power, spectrum, density. Could explain you everything about power, spectral density as well. Interestingly enough, when I ask again, it didn't use the Python, didn't generate any code. It was referring to EEG Lab and M&E Python. So yeah, we're kind of trying to avoid MATLAB because it's not open source, and avoid M&E Python as well because it's a bit clunky, old, and we want to do things ourselves. So the first response was much better, where it actually generated an example that, well, it would not work. It needs the coefficients, but the questioner actually said that they were able to get the coefficients. So this will not work for us, but more than happy to share that the code. I'll keep that email led to the person who asked the original question. Now GPT-4 was GPT 3.5. It generated an example. It was a shorter example. I'm not quite sure what's missing. And PSD coefficients as well. So it's kind of hard to tell which one is better. Obviously, shorter seems better, but then what's missing is the question. Yeah, again, 3.5 was quite good in turning the original message into actual prompts and questions and start answering them one by one. This one using a Welch function to calculate PSD. That one it was using something else, so you can obviously have something comparing different methods of calculating PSD. Could be another video. Pretty much do anything that the GPT or any bot or the Copilot bot is able to generate for us. Right, and that's on the same topic, and that generated somehow a much more comprehensive response. Oh, and it's actually using the data, I forget what it's called now. It's the it's actually executing code online on the OpenAI server and spitting out the output, which is good. In this case, it was trying to simulate some EEG signal. Didn't do quite a great job. Can improve it. We actually have a simulated EEG on this site as well. Yeah, synthetic EEG signal generator. Yeah, we need to change that image because that's the original lab view example. Now we're doing everything in Python. Yes, so telling you which libraries to use. Telling you that you need EEG data, obviously, but yes, you can simulate. One simulated data obviously is sometimes even better because you can actually test your algorithm in a more precise fashion. So you can actually inject more alpha or beta waves and actually see that your algorithm is working as expected. something that you cannot do with real data. Then it's doing a discrete wavelet transform with db5 wavelet. I have a tool that where you can select different wavelet types, so you can see what difference it makes. Extracting coefficients is gamma, yeah, between 30 and 100. Yeah, I have to double check the details of everything it says. Is something that are common knowledge, so it never gets it wrong, but other times, yes, that's hallucinate. I didn't come across any major hallucinations. I mean, especially when it generating code, you actually know if it's working or not, so that's your proof of lack of hallucinations, if the code is actually working. Like the subplot business. But other than that, obviously it has all this missing stuff, but it should give you an idea of how to get going. Yeah, a lot of datasets have the files in MATLAB files, which is unusual for EEG. Normally EEG will has its own file formats. And yes, Python should have a conversion method from, well, pretty much any file format. That's something of great interest as well, because that's what most people are struggling with, is converting the data from one format to another. Shell selection is a big thing. Some channels might not work well. Should be able to just monitor signal quality on each channel. So if you have an impedance measurement or something that could help you select a channel, you shouldn't be just looking at it. But that's coming from engineering standpoint. Clinicians will just look at the wiggly lines and make all sorts of decisions. But yeah, sometimes it's a bit of a magic voodoo type of activity. Wavelet transformation, transforming suitable for each analysis, set the parameters of the wavelet, and yeah, a lot of visualization options, tips and suggestions. Yeah, take advantage of any community forums. Great idea. So might jump. So we said we're gonna be deploying today, but first we need to turn the fuzzy application app into, need to add another Flask application before we can deploy it. That's how it looks like at the moment. You can select your input wave from a drop down and change the amount of noise. Yeah, obviously a signal that should be unrecognizable, so you expect the wrong output, or ideally it should say I don't know, which is an option in the code. When there is no noise, it should give the correct response. In this case, a triangle should return a triangle. However, the current settings of the fuzzy logic are not quite right, so we have to adjust them. Ideally, so I don't know if this tool should also have a controls somewhere, probably at the bottom, of actually how to adjust the symmetry and sharpness membership functions. So we're looking in the two features in these signals. We're looking at the symmetry and sharpness. So a triangle wave in this case should be symmetric and sharp. Then we also have left and right triangles, which are different. Probably look more like trapezoids. It should adjust this to look like a spike, because this will imitate epileptic spike. So even triangle doesn't work at the moment. It's producing an output saying it's a trapezoid. Trapezoid saying it is a trapezoid, so that's great. And we see the rule activation. It's mostly the trapezoid rule is being activated. Once we add more noise, you can see, yeah, it starts making mistakes pretty much. Over here it's already saying unknown. I don't know. Yeah, the Centroid is all the way this. Yeah, we also need to plot. We need to add a couple of plots to this. We need to plot this kind of stuff. That's the selection. So essentially saying if the Centroid is below 0.2, the output is a square. If it's below 0.4, the output is a triangle. Below 0.6, trapezoid. And above 0.6, it will produce unknown. Yeah, like in this case. So this will be a trapezoid in the middle there. So why it's jumpy, like that. It shouldn't be jumpy like that. Yeah, so this will require quite a bit of work. I don't know. So the original idea was to have the same tool using neural networks. So essentially we'll be trying to see which one's better. Obviously, it will depend on the task at hand. The fuzzy logic in LabVIEW, there was the tool to actually design the parameters. Here it's all text based, so I don't have the tool. So what should we do next? Should we yeah, there's nothing to deploy because it doesn't really work. Well, it doesn't work well. We're trying to. Shall we try? Last time we tried the GPT-4 without much success. How about today we go for GitHub? A Copilot. So we have the tool, we have GitHub. That was a different app. We can close that. Close that for now. It doesn't look like we're going to be deploying just yet. Yeah, don't like those. The trapezoid function. can fix it later. So there's a couple of options for improvement. We could add another feature. I think two should suffice for now. It's okay for making some mistakes, it's fine. Just trying to learn. The question is how we can improve. In the Centroid function, we had also a funny Centroid that wasn't a standard one. Yeah, mom. It's the minimum of a mean of maximum. Centroid of area would be obviously a more standard thing to use. Yeah, we actually expected it to work with the Centroid. Everything should be more or less standard. The white detection error went from 100 to now square doesn't ever give square. We also need to monitor the features for each selected waveform. To monitor the features. The JavaScript should be pretty straightforward because most of the stuff we doing in the back end, which is not ideal for a BioniChaos, should all be doing everything on the front end on the client side. Then you will have options to do more on the back end on the server side. That's yeah, server can be costly, and considering these tools are free, I want you to spend electricity and not overload my server as much as possible. Question. So if we load all the code, in theory should have been able to use this workspace. Can you explain the link between between the files in the workspace. So it's getting errors when using workspace. It's essentially collecting too much stuff or something. I don't know what's up. Don't know what's up with that. I bet it will work on Windows. Can I do? Curious if I can just do this, send it to a GPT, see what it says. What the problem might be, I'm using Ubuntu. Is this a unique problem? Get this array buffer allocation error failed.
This error message typically indicates that the process has run out of memory or that it's trying to allocate more memory than is available. On Ubuntu, or any other operating system, this can happen if there's insufficient RAM or swap space to allocate the new buffer.
Nah, this can't be right. This can't be right. I have plenty of RAM. I think it's also happening on the server side. I do have plenty of RAM. I think the problem is happening on the server side of GitHub Copilot. Yep.
If you have sufficient RAM on your local machine and you believe the issue is on the server side of GitHub Copilot, it's possible that the server running your Copilot instance is experiencing memory allocation issues. This could be due to a bug, a limitation in resources allocated to your session, or an outage affecting GitHub services.
Okay, GitHub is working fine. Can monitor memory usage, but that's shown won't be it, would it? It should be a more simple command for Copilot. So I don't know. Anyway, it doesn't seem to work on Ubuntu properly. At least the workspace command, which meant to look at all the open files. It's collecting workspace structure. Yeah, buffer allocation. No, there's nothing wrong. Yeah, it's using bugger all memory on my machine. Guess we asked about each file, to explain each file. Let's go back to the JavaScript. we need to modify the fuzzy logic parameters. What are we currently looking at? What are we visualizing in terms of the fuzzy logic parameters? To change them, do we need to visualize other parameters? This one I have to speak quickly because it's just sending it as soon as you stop talking. Yes, we have the membership functions, symmetry and sharpness. We have the rule activation. It's plotted this graph with the x-axis representing the symmetry. Symmetry. Assuming the same x-axis for all rules. Okay, this is odd. An aggregated output of the fuzzy inference process is plotted as a graph on the x-axis representing symmetry. So rule activation. But the rule activation is working for both symmetry and sharpness. Yeah, we do need to modify fuzzy rules to change how the system makes decisions, because currently it's making a lot of mistakes. Depending on the nature of the parameters. For example, if you want to visualize input fuzzy sets, do we need the input fuzzy sets? Yeah, so we have both symmetry and sharpness parameters in low, mid, high. Should be able to view the input it keeps saying stuff is not provided on the server side, even though we did provide the Python code. So I don't know what's up with that. Functions. Yeah, we should be able to plot. Yeah, that's the problem if Copilot doesn't have all the context. Start from. Let's do this quickly. do it in a different order.
Your Flask application for analyzing waveforms with fuzzy logic seems well structured, but there are issues with the accuracy of waveform classification. The incorrect classifications of square and triangle waves as trapezoids, and the left triangle as unknown, suggest potential improvements in the fuzzy logic rules or input feature calculations. To enhance the accuracy of your classifications, consider the following steps. Refine membership functions. Adjust the shapes and ranges of the membership functions for the symmetry and peak_sharpness features. The current trapezoidal membership functions might not accurately capture the characteristics of each waveform type. Improve feature calculations. For symmetry, ensure that it effectively differentiates between symmetrical, like square and triangle waves, and asymmetrical waveforms, like trapezoids. For peak_sharpness, refine the calculation to better distinguish sharp peaks, as in triangle waves, from more gradual slopes, as in trapezoids.
Okay, can we add more visualization that will help us to modify the fuzzy logic parameters? The HTML should be pretty straightforward. Yeah, we need the input features.
Display graphs for each input feature, symmetry and peak sharpness, alongside the original waveform. This will help you see how changes in the waveform affect these features.
Okay, how do we do that? Can we now use GitHub Copilot to change the code? So we have the prompt. Well, it's not quite a prompt. Should have asked to turn it into a prompt. Yeah, of course, we need to modify the JavaScript. And in the HTML, yeah, I want to edit the HTML. Where do we put it? It's the output graphs. We have the input graph, output graph. Place this two over here. I have obviously a problem of fitting everything into that one window. Then the JavaScript. So it's a scatter plot. That makes sense. Turn this into a prompt. I don't know. In theory, it's using GPT, but in reality, yeah, probably shouldn't be asking silly questions like that. Should just give it. Does it know of a previous prompt? How to modify the code based on the previous prompt? Now, why are we calculating symmetry? Doesn't make any sense. We already calculated the array, so we'll have calculate wait, why is this? We have it in the back end. We need to pass it to the front end. When we calculate symmetry array, can we turn it into, okay. When we calculate symmetry array, can we turn it into one number? How is current decision being made out of the array, considering we should have a single value for each input waveform? Yes, essentially what I don't understand is currently we have the algorithm searching for certain waveforms through over time, but when you have a single response, it's calculating symmetry measures for each point in the signal. Yeah, that's not what we want to do. This is not what we want to do. Yeah, I think we need a GitHub for this. To already place Flask. Yeah, I'll place the Flask first. In the current code, I haven't made any changes. Why are we calculating sharpness and symmetry for each data point in the code instead of for the whole input waveform? Yep. Yes, that's wrong. Generating super slowly. Might take a break while it's generating.
The current approach in your code calculates symmetry and sharpness for each data point in the input waveform rather than for the entire waveform as a whole. This method has distinct advantages, particularly in the context of fuzzy logic and waveform analysis. Local feature analysis. By calculating features like symmetry and sharpness at each point, the system can assess local properties of the waveform. This is crucial for detecting variations within the waveform, which might be lost if you only analyze these features on the whole waveform. Detailed classification. Analyzing each point individually allows for more detailed and nuanced classification. This is especially useful in scenarios where different segments of the waveform might exhibit different characteristics, e.g., a waveform that changes from a square to a triangle shape.
Okay, so that's wrong. But I don't want to force it on it. Just let us get upset. How is it possible to calculate symmetry for a single data point? Yep. Don't you need at least 2? Yeah, it does sound counterintuitive.
Calculating symmetry for a single data point in a waveform indeed sounds counterintuitive, because symmetry, by definition, involves comparing two halves of a structure to assess their similarity. However, in the context of signal processing in your application, what's likely happening is a localized symmetry analysis around each data point. Here's how localized symmetry analysis might work. Windowing around each point, for each data point in the waveform, you consider a small
Could you give me specific responses to the code I uploaded? I don't want any generic stuff. Any generic. Really struggling with the text to speech.
Windowing around each point, for each data point. In your code, calculate _symmetry _array function calculates symmetry for each data point in the signal. This is achieved by creating a window around each point and comparing the left and right halves of this window. The code ensures that this comparison is only made when the halves are of equal length, which is crucial for a fair symmetry assessment. The calculate _peak _sharpness _array function measures how sharply the signal changes at each point. It does this by calculating the average absolute difference between a point and its immediate neighbors.
Okay, so there is some misunderstanding. There is a misunderstanding. The input wave is a drop-down menu to select a waveform of a specific shape. Now the fuzzy logic algorithm should then look at the entire wave, and in the output wave make a decision what the waveform is or which group the waveform belongs to. Can you double check the code and suggest how to fix this issue? Yep.
In your existing implementation, you calculate symmetry and sharpness for each point in the waveform, but for the purpose of classifying the whole waveform, a different approach is needed. Here's how you can adjust the code to analyze the entire waveform. Symmetry. Instead of calculating symmetry for each data point, calculate the symmetry of the entire waveform. This involves splitting the waveform in half and comparing the two halves. The symmetry calculation could be the average difference between corresponding points in the two halves.
I thought that's what the code was doing already.
Sharpness. For the whole waveform, sharpness could be interpreted as the frequency and intensity of peaks and troughs. This might involve measuring the differences between peak and trough values, or the rate of change across the entire waveform.
Yeah, there's one problem with sharpness. We also have an option to add noise to the signal. Can we somehow make sure that sharpness is not affected by the noise too much? The noise is much higher frequency than the changes in the whole waveform. Yep. It should be somehow embedded into the sharpness calculation.
Adding noise to the signal and ensuring that the calculation of sharpness is not overly affected by this noise requires a careful approach. Since the noise is of a higher frequency than the changes in the whole waveform, you can use techniques to separate or mitigate the impact of this noise on your sharpness calculation.
Yeah, so we don't want to use low-pass filtering because, yes, it will be getting rid of the noise, but we want to feed the noisy signal into the fuzzy logic and just see how it able to deal with it or not. That's okay if it's not. We want to see at what threshold of noise it starts making mistakes. Yeah, I want to ignore this for now. That's okay. Yeah, I want to try something I haven't tried before. I want to generate prompts. Potentially generate prompts from GPT-4 and actually ask the Copilot to do the code changes. That work any better?
Update the calculate_waveform_symmetry function to assess the symmetry of the entire waveform. This function should take the entire signal as input, split it in half, and compare the two halves. Calculate the symmetry as the average difference between corresponding points in the two halves. Also, include handling for waveforms with an odd number of points.
Let's see. Let's calculate waveform symmetry. Let's check if everything. So before we had an array, right? Because it was calculating it for each data point. Okay, can we just have it in the code? Let's try this. Let's comment this out. And now we have calculate waveform symmetry function to assess the symmetry of the entire waveform. It sounds better. This function should take the entire signal input, split it in half, and compare the two halves. Calculate the symmetry as an average difference between corresponding points in the two halves. Also include handling odd number of points. What? It's already like hallucinating. I just said calculate waveform symmetry function. Why on earth? Don't understand it. So obviously taking it from the code above. Okay, midpoint, right half, left half. There are giving three different options. Obviously GPT-4 only gave one. Yeah, return symmetry is okay. Turning symmetry. Just 1 minus symmetry measure, or 0 if the lens so is it handling? Well, yeah, it's returning as 0. So it's kinda is handling it, but yeah. So I like that the prompt is nice and clear. What? There's something weird happening, like a keyboard thing when I go Control. Trying to comment something out. Oh, come on, it's happening again. Then the keyboard stops working. Command helper function, find pics, find detect these features. Okay, that's legit. Peaks, find peaks. Troughs, find troughs. Again, suggesting couple of options that are actually quite different. Returning sharpness. This is modify the fuzzy logic function. Develop find peaks. 5 trough functions to take peaks and throws in a waveform. Sure, this function applies to noise can accurately identify significant peaks and troughs. Let's symmetry array. We don't need to calculate symmetry array anymore, hopefully, because we also need to modify the fuzzy logic function. Let's do it in the chat. Okay, now it's going places, isn't it? But we're already doing that. It's again always reverting to use triangular membership functions instead of trapezoidal ones. Okay, anyway, hopefully after this update it will do something more useful. And it should appear on BioniChaos.com soon enough. Please check BioniChaos.com if you haven't done so already. Provide your feedback. This is what we do in these live streams, so don't forget to comment, subscribe so you don't miss the next live stream, and I'll see you in a bit. Bye.